Hi there everybody, today we are going to be looking at intersecting chords and intersecting secants. Okay, so just for clarification, a chord is a line that goes from one side of a circle to the other, but not through the centre, and a secant is a line that cuts through normally a curve, but it can be a circle at two distinctive points. Okay, so that's kind of the definition. But as we go through these, you'll recognise them by the look at them, I would assume. Okay, so let's get started anyway. So, a couple of things that I'm just going to talk about. One, first of all, is just a rule, which is worth knowing. And then we're going to look at intersecting chords in a bit more depth in a particular problem. All right, so the first one I'm just going to want to make you aware of more than anything else. If you've got a radius which is bisected by a chord, all right, so just have a look at this one. So this is your radius, and this is the chord being bisected. So this bit, the length is the same as this length. Then they are perpendicular to each other, therefore they meet at right angles. And of course, that notation there represents its right angles. That's just something to kind of bear in mind and something to look out for in potential exam questions. This idea of that if you've got a chord and a radius going right through the middle of it, then it bisects it and it will be at right angles to it. Okay, so just something to be aware of. Really, the main focus of this particular part is this rule over here. So if you've got two intersecting chords and split into two lengths, then the product of the two lengths of each chord is equal. All right, so you can see from the example or the demonstration or the diagram, I should say, is you've got a chord here going straight along there, and then you've got a chord which kind of cuts it through there. All right, and you'll notice that this time they're not bisecting each other at all, so that's something we don't need to worry about. But the rule here is A here times B, so that length times that length is the same as this length times this length. Okay, so that's the rule of two intersecting chords, and of course that can be applied with particular problems which we are going to look at now. Okay, so what we've got here is the first example, and hopefully you can see from this particular example, this is using the first rule over here, where you can see that you've got this line and this line, and these little lines that basically are showing here are the notation to show that this length is the same length as this. All right, so what it's telling us is that it's bisected by this line, which of course is a radius, but also goes straight through, so technically it's a diameter as well, but therefore that is a right angle, and it wants us to calculate this value x. All right, so if this is a right angle and this is 65, then what we're looking for is a triangle here, which therefore means the angles in a triangle add up to 180. So 180 take away the 65 and the 90, which is here, is going to give us the value of x. So 180 is equal to 65 plus 90 plus x, or like I said, 180 take away those two, and it's going to be 25 degrees. So that's the value of that. All right. The second example we've got, well, this is about the second one over here. And like I said, this is probably the one that you're going to come across more often than not. So you'll see from the example, I've got this dimension, which is 5. I've got this dimension, which is 3. And I've got this dimension is 9. And it's bx, which is this one, which is missing. And of course, that's the one it wants us to calculate. All right, so we're going to use the rule, which is kind of demonstrated above, where we say that times that equals that times that. So what we can say is 3 times 9 is equal to 5 times something. All right, and that's really what we're going to write down here. All right, so you can see we've done it with the notation ax times bx is equal to cx times dx. All right, so we write that out. We say 5 times bx, that's our unknown, is equal to 3 times 9. So therefore 5bx is equal to 27. And then a bit of division, 27 divided by the 5 here is going to give us bx, which is going to give us 5.4 centimetres for that particular question. Okay, so that's the rule for that particular one. Right, so that's chords. So we're now going to move on to secants. Secants are lines which cross a curve at two particular points. When thinking about a circle, your scenario is going to look a little bit like this. So what you've got two lines. Okay, so a line which cuts the edge of a circle once, and then again twice, and that could carry on but we don't really need to worry about that because the rule is about just going to the end. And then we've got another secant, which again kind of comes along here, and we're talking about intersecting secants, so they need to kind of cross. All right, so the rule with this one, as you can see already kind of written down here, is the A multiplied by the total length of this, so A plus B, is equal to C multiplied by the total length of this, so C plus D. All right, so that's the rule, and of course we just need to see what we've got and apply it. This is going to come in two parts. There's going to be two examples for this one, because you'll notice that the first example is relatively straightforward and the second is a little bit more challenging, and that's really dependent on the questions. And again, in an exam, depending on obviously the difficulty of the question and where it sits in the paper may determine what kind of you need to do. But I'm going to go through to both, so you're prepared for either or. All right, so let's have a look at the first particular one. So we've got the dimensions for the first secant, where we've got 7, which is XAX or XA here, and we've got 5 for AB. And then along here we've got XC, which is 8, and of course the missing dimension, which is CD, and that's the one it wants us to work out. All right, so applying the rule, which we've kind of given above, I'm just going to put the letters in. So you've got AX, which is this one, plus these two added together, is equal to CX multiplied by these two added together. All right, so when we write that out, I'm just literally just going to put those numbers in so you can kind of see. So you've got 7 times 7 plus 5, so that's okay, so that's 7 times 12. And then we've got 8 multiplied by 8 plus CD. All right, so we've got a slightly different situation on the right hand side than we do the left hand side, but it should be okay because we're going to deal with this bit on the left first. So 7 times 12 is going to give us 84. All right, the first bit. And then over here we're going to do 8 times both of these two. All right, so that's going to give us 64 for this bit, and all we can write for this bit is 8CD. Now you could label it and give it a letter, but we're going to stick with CD for this particular example, so you'll see that written out. So I've got 7 times 12, which is 84, 8 times the 8, which is again the 64, and then plus 8CD. And then we're just going to rearrange this, so 84 take away 64 is going to give us 20 equals CD, which we've got written here. And then from the next particular bit, we're going to say CD is equal to 20 divided by the 8, which is going to give us 2.5 centimetres. All right, so that's the value of CD. So we're okay. That's quite straightforward. The second example is a little bit more challenging, which you'll see the dimensions have changed. And you'll notice that what's happened in here is I've still got length of a total secant, and I've got the 6 and the 5, but I've been given the value of CD rather than this one. And that just makes it a little bit more awkward when I put them into the formula, which you'll see when I kind of do it. So when I put the values in, same as before, I've got AX times AX plus AB. It's the same for the top one. And then the bottom one, I've got CX times CX plus CD. All right, like before. But when I put the values in, you'll notice slight change here. This bit looks the same, but over here I've got CX's in both of here. And that just makes it more complicated, because what I did last time is I did CX times the 4 and I did the CX times the CX, and I need to do that this time as well. But when I do that, I get something a little bit more awkward, for want of a better word. So let's do that, because that is the right process and that's what we've got to do. So I'm going to do 6 times 11, which is going to do 66. And when I multiply this bit out, I've got CX times 4, so 4CX, and CX times CX. Remember, this is the unknown, we don't know what it is. But because these are both the same, it's CX squared. What you've actually got here is a quadratic. All right, so I'm going to just manipulate it a little bit and just say, well, let's just let CX equals X and write it as a quadratic. So literally put it to make it equal to 0. All right, so all I've done here is I've changed this CX to an X and called it X squared. I've changed the CX to an X and called it 4x, and then I've moved my 66 across to this side and made it minus 66 to make it equal 0. So what I've got here is what I'm familiar with in terms of a quadratic equation. So what I now need to do is solve this quadratic. All right, there are different ways of doing it, of course, and please do go on to mycyberschool.co.uk and look at the lesson on solving quadratic equations, because that's what we now need to do. Now this one does not factorise at all, and I'm aware of, certainly not. So it will require you to use the formula, all right, the quadratic formula, which is x is equal to minus b plus or minus the square root of b squared minus 4 for AC all over 2a, which I'm sure that you will memorise at some stage. But I'm going to show you that. All I'm going to say to you is you need to use the formula to establish what the value of x is, and when you do that, you will get these 2 values coming out from your calculator, which is 6.366 or minus 10.366. You often usually get 2 solutions, but we've got to decide which is the correct one. Well, this is a length, so this length here must be positive. It can't be a negative length. We've got that negative length, so I can eliminate the minus 10.366 and safely assume my solution is 6.366. So that is my answer, 6.366 centimetres for the length of CX. So hopefully you can see that it's a little bit more complicated, and that all that kind of came from was that variation of which one was missing, this one or this one. Okay, so like I said a bit earlier on, depending on where you are in the paper, depending on where it kind of sits within an exam, will determine which kind of side it sits. If they want you to really challenge and give you the quadratic part of it, then they're going to put that unknown there. However, if they want to make it a little bit more straightforward, then examiners will put the unknown on this side, and you'll remember it was a little bit more straightforward. All right, but either way, understanding this formula is the key part of that particular thing. Okay, well, thanks for listening, and by all means, get yourself onto maths-school.co.uk and have a go at some of the questions which are on there.